which is the larger problem. Tracking all of the vectors from all light sources, tracking vectors fixed through the pixels of the actual display screen.
Tracing all the vectors from the light sources.
Well, this top one is an unbounded problem, right? Totally unbounded. This one is bounded by what? Well, it's bounded by the resolution of your screen. If you have a 1024 by 1024 screen, which is today pretty low resolution, but if you have that, what do you need to do? Well, instead of catching the pixels this way, you just need to fire pixels through every one of these, fire a ray through every one of these pixels and go back and trace it backwards to the light source. Okay, a much smaller, much more bounded problem, because in ray tracing you have kind of two models that you can work with. You have this parallel view model, so this grid represents pixels on your screen, and you can fire a ray through every intersection, or you can fire a ray through the center of one of these boxes. And depending on the algorithm that you use, they either fire 1 through the center, or they fire 4, and then they average those 4 values for that particular pixel. Okay? But it's still a very bounded problem. The other option is a perspective view, where someplace out in front of your screen, of your display, you've got a point, and it's from that point that you begin firing rays. But again, you fire rays only through the grid. You don't have to go outside your window shooting, left and right, top and bottom of your display screen. So there may be 1 million vectors that get fired. That's still so much smaller than the other problem where you're taking every ray off of every light source and trying to track it down. It just is an unbounded kind of problem. So if we know how to fire rays back through the scene, what are you looking for? Let's go back. If you fire in this top image, you fire a ray through this lower left quadrant, and you're firing it straight back in, what are you asking? What's the question that you're asking about this line? We call it a ray. What are we asking it to do? We're asking if it intersects any geometry, right? Does it hit object 1? Does it hit object 2? Does it hit object 3? We just ask the question, does this line intersect a surface, a solid? If it doesn't intersect it, if it hits it, then what do we have to do? We have to ask, at what angle does it hit it? Okay? And if it hits it and never goes back to the light source, what color do we put on that little square? So we fire a ray, it goes back, it hits, let's say, a box. We ask it, okay, what angle did it bounce off the box? And in bouncing off the box, it never intersects with the light source. What color do we paint that up? We painted up the ambient color. We painted up just the general illumination, the general color. If, however, it hits and goes right to the light source, then we put it as a shining model, not as a diffuse model. I've got an example of that a little further on. So now, how do we actually determine the right color? How do we put a color on one of those pixels? So we're just dealing with a single pixel. Well, there's 2 hardware solutions that used to be very, very common. The back of your computer terminal used to have 3 cables that come into it. And the 3 cables were either RGB, red, green, blue, or they were CYM, cyan, yellow, and magenta. Okay? So those don't exist anymore. We just have a regular kind of flat screen monitor, and it's because they've all done it in kind of software. They've done a hue, saturation, and intensity model, and it's built off of this double cone. So going from this point at the bottom all the way to the top, you go from basic black all the way to white. What's that?
He was just talking about the lab color system, how it's similar to that.
Yeah. If you just go straight up the axis, you're going from kind of black through grays up to white. Okay. If you're coming out kind of on the diameter of these cones, then you're really dealing with the saturation. And the saturation goes from 0 out to 1. And 1 would be, if it came straight out, it'd be red. And then based on the angular position around this cone, it's where you pick up the different colors. So 3 parameters: a value for the hue, a value for the saturation, a value for the intensity, will give you up to over 1 million different colors or different intensities that you can work with. Okay? So there are 3 different lighting models that we're going to talk about. The first one is what's referred to as the ambient lighting model. The ambient lighting model is a simple, and right now all we're dealing with is the I component of the HSI. So we're not talking hue, we're not talking saturation, we're only talking intensity. Okay, how much light is hitting this point. And for an ambient model, you have 2 parameters. You have basically the intensity of the ambient light, and you have the roughness of the surface based on the ambient light. How do we get those values? How does a photographer get those values?
Don't they have a light meter?
They have a light meter in their hand, right?
Yeah.
And the first thing that they do is shut off all the floodlights, right? And they kind of wander around the room, and what are they doing? They're reading kind of the average ambient light that's in the room. That is this IA. They're just holding it around, wandering around, looking at it. What do they do when they hold, it's still ambient light, when they hold the light meter up close to the wall? What are they reading when they go over to a different wall or up to a table? What are they reading?
The reflectiveness.
They're reading the Ka factor, okay? How much ambient light is really coming off of these surfaces, okay? So they're trying to get a general understanding of what the scene is like when there's no floodlights on, okay? And so this is a basic kind of a flat shaded image. So when you say turn on solid modeling and give me a rendered image, you've got a material property assigned, and you say render this thing, and there's really no lights or anything set up, you're getting this model. Okay? The next one that we talk about is where they include the diffuse reflection as another component. So in here we have an intensity for the light source. We have kind of a material property as to how the light, this spotlight, is kind of bouncing, reflecting. This really isn't a spotlight. It's more like floodlights, room lights, things like that. And the cosine theta is the angle between the incident and the normal to the surface. Okay? So these little examples across the bottom, this one on the left basically is kind of diffuse lighting where you have both The IA and the IL are set up to